Hi, it's Argon here. I'm here to discuss for AP Chemistry the assignment on periodicity. I want to give you some explanations of what I'm expecting. For example, number one, it says define the terms periodicity and periodic law. One or two word definitions are not acceptable. I'm looking for several well-written paragraphs. I would like for you to Google periodic law, periodicity, and I want you to discover the men responsible for this, the who of periodicity. When did they do their research into how the different elements on the periodic table are organized by their characteristics, by their activities or reactivities? So who? When? What did they discover? What is periodicity or periodic law? It is, very briefly, very simply, the realization that the elements on the periodic table are organized or grouped, placed into periods, and we find in these different periods and in these different groups that the elements have similar characteristics. So discuss that. Discuss the men responsible, when did it take place, and what did they actually find. Next, paragraph 2, or number 2, says characterize in as many ways possible the periodicity of groups 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A. This is all the A groups, and skip the for now skip the B groups, or the transition and intertransition metals. And I want you to take each one individually and describe the elements in these different groups, their appearance, their activity, their reactivity. For example, group 1A, the alkali earth metals. Okay, the alkali earth metals. Not hydrogen, of course, but lithium, sodium, potassium, rubidium, cesium, and francium. You know from class that these metals are violently react with water. You know from our discussion that you cannot find them by mining in the earth. They just don't exist in their elemental form. So discuss their characteristics. They have the same electron configurations, and their electron configurations are some of the reasons why they are so violently reactive. You need to discuss their ionization energies and how it increases and why it does in a certain way. For group 7A, for example, this is group 1A, group 7A, all the way across, known as the halides, which is Greek for salt formers. Not easy to find them in their natural state on the earth. We find them in compounds, just like group 1A. So we have these two groups, very interesting groups. We've got 1A, the violent metals violently reacting with water. We have group 7A. We've got fluorine and chlorine, two gases. We have bromine, a liquid, and iodine, a solid. And these are all very dangerous elements. Yet when you combine group 1A with group 7A, you've got some of the most useful compounds on Earth. Sodium chloride, preservative, a spice, a salt, something we put on our food to make it taste better. Sodium fluoride, used in toothpaste. Bromine, used in chemicals to put in your pool. Bromides, used for antibacterials in swimming pools and so forth. So these elements are very, very useful in compound form, very, very dangerous in elemental form. They have similar characteristics. So discuss that, and do that for each of the 1A, 2A, 3A, 4A, 5A, 6A, and 7A, and also discuss the 8A or 0 group, the noble gases. And that's number 2. Number 3, it says, why are the transition elements or metals so named? What are the inner transition metals? How do the transition metals differ from alkali and alkaline earth metals and groups 3A, 4A, and 5A metals? What unusual bonding properties do they exhibit? You can pretty much stick to period 4, okay? Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, and zinc. You'll find that these have unusual electron configurations. They aren't straight increasing like we see in the A groups. And I want you to discuss why. Find out the different properties of the period 4 transition metals. You'll find them very interesting, and they are the most common that you'll find in different compounds. So discuss the transition metals and the intertransition metals, and why are they called this. Their electron configurations are unusual, but they follow patterns that are typical of the transition metals. Number 5, it says to define using a paragraph for each on a rectangular, or define using a paragraph for each. Then, on a rectangular diagram, indicate with directional arrows the direction of increase, strength, or magnitude for atomic radius, ionic radius, electronegativity, ionization energy, and electron affinity. Let's take electronegativity, for example. You can give a definition for electronegativity. As you know from our discussion in class, electronegativity is at least a tendency of an atom or element to attract electrons to itself. Okay? It's the tendency of an element to attract electrons to itself. That's a very simple definition and not a complete one. But give a paragraph definition, description, and for example, you might want to discuss how we got our numerical system for electronegativity, who assigned a number 4 or a magnitude of 4 for fluorine, and how the other ones down from there were assigned, who and how they were done. And then for each one, I want you to draw a box with directional arrows. For example, francium, the least electronegative element, down in the bottom left, right down here. And then fluorine up here. Okay, fluorine. Fluorine is the most electronegative element on the periodic table. Francium the least. And electronegativity increases directionally like that, or and up groups and families, and across or to the right in periods. So show with directional arrows the area of increase. Okay, increase of electronegativity, or EN, electronegativity. Okay. Next. Number 6 says, give an example of each of the following: cation and anion. Explain how they are formed. How do their atomic radii? How do atomic radii compare with atomic radii? It probably would be helpful with this part to include some drawings. For example, you might want to discuss the sodium atom. Okay, sodium atom has one valence electron, and between the nucleus it has, with 11 protons, and between those two there are 10 electrons. Okay, between the nucleus with its 11 protons and the valence electron, the one valence electron, one valence electron of sodium, 10 electrons in the center. That's for the sodium atom. And it has a definite atomic radius from the nucleus out to that outside electron. Okay, what is its radius, atomic radius? Being a metal, when it bonds with nonmetals, it loses an electron and becomes the sodium ion. Na+. And now it has 11 protons in its nucleus, and now it's got 10 electrons outside of it, organized in 2 in the inner shell and 8. Not like the Bohr model, but with the Schrödinger model. But I drew it this way for simplicity and for quickness. So discuss that and include some drawings. Number 7 says contrast and compare these. Electronegativity, ionization energy. You might find this a little difficult, but only compare and contrast those that they're capable of doing. You may not find comparisons of some, but the ones that are similar, please do that. And lastly, it says a 3 to 4 paragraph biography of Dmitri Mendeleev and his periodic table, and trace the development of the periodic table from his time up until now. The periodic table is in a state of flux. We have discovered, actually we've named these here already. These are named, and a few more. We've discovered elements almost all the way to 118. There's a couple of gaps here, okay? A couple of gaps along here. So, what does the periodic table look like today? What did it look like in Dmitri Mendeleev's day? How did he come up with his idea? How did he organize it? Why did he leave gaps in his periodic table? What was his intention? How do we allow elements onto the periodic table today? Discuss, if possible, where do we get these elements? How do we discover new elements, and why are some of them so short-lived or short-lived? So do your best on this paper. I'm not expecting a neatly written book. I do not want you to write 10 or 15 pages. I also would be not interested in just 2 or 3 pages. I'm looking for something between there that is a good, detailed discussion that shows that you have learned and possibly mastered the concept of periodicity. As always, call me if you have any questions.